morning, everyone. Today we're going to be doing dilations and composites. A composite is a combination of multiple transformations, so it's kind of everything we've done before, just kind of mixed together. So here we have a quick do now just to kind of review. Excuse me. Just to kind of review the last section from Friday. So the first one is just asking you, if you rotated it 180 degrees, how would it look? So 180 is a half a circle, so that would be this one here, D. That's how that would look. Doesn't matter which way you're going, the 180, again, 180 could be clockwise or counterclockwise, same thing. It'll be that. Excuse me. There go my yawn. As soon as I start recording. Next one, triangle ABC in the coordinate plane. This is saying 90 degrees. Again, if it doesn't indicate a direction, the default is counterclockwise. So again, hopefully you wrote down the rules last week from the rotations video. But when it's I'll just write them down here. When it's 90 degrees counterclockwise, they switch places. Excuse me, and once they switch places, the now y value will be a negative. When it's 180, they switch places. I'm sorry, they don't switch places, they change signs. When it's 180 clockwise, they switch places. Oh, excuse me, and this time the x changes signs. All right, so let's just see what the new coordinates are going to be. So for A prime, if we're applying this rule, they're going to switch places, so it'll be -6, -3. B prime will be -1, -1. Again, when they switch places, excuse me, if you don't see anything indicated here, that means the sign stays the same, so it doesn't have to be a positive. And then for C, it's going to be -1, -5 to rotate 90 degrees counterclockwise. For 180, again, they're just changing signs. So A prime is going to be -5, -6. B prime is -7, -1. And C prime is -3, -1. And for a rotation of 90 degrees clockwise, M is going to be 5, 3. N prime is going to be -2, 6. And P prime is going to be 3, 6. All right, so let's go to the new stuff. All right, so for today, we're going to start with dilations. This is the last of our transformations. Yay. As we spoke about from the beginning, a dilation is an enlargement or a reduction in the size of a figure. Excuse me. This example here represents a dilation where the D is getting larger. It's an enlargement. The key thing, again, from the beginning when we spoke about this, is that the dilations are not isometric. And that means, again, the pre-image and the image are not congruent. Right? The next term we need to know with dilations is that orientation is preserved. Again, the only one of our transformations that does not preserve orientation are the reflections. All right. The next mention about dilations is that the pre-image is similar to the image. That's what this tilde means here. It means similar. What similar means is essentially that they are proportional. The figures have corresponding sides that are proportional. So what that means, you guys have dealt with proportions a few times in middle school, etc., algebra 1. It means that if like this was 3, that this could be, let's say, 9. So basically the proportion is that you're multiplying by 3 to go from 3 to 9. So if this was 4, then you would expect this to be 12 because I have to have that same ratio or that same proportion. And then the other thing, so basically that's what it means by the corresponding sides being proportional. And if they are excuse me, if they are similar, the corresponding angles are congruent. So this is something we'll get into later when we do the chapter on similarity. But if this was my two figures, just know that the angle measurements are the same. So angle A and angle A prime are congruent. Angle B and angle B prime would be congruent, etc. But sides are proportional, but the angles would remain congruent. Any like parallel stuff would remain. Only thing that doesn't stay is distance. All right, one of the other features about the only feature about the dilation that's really important is going to be the scale factor. Excuse me. The scale factor, we'll use N for the scale factor. Now, there's a few restrictions on the scale factor, so let's just make sure everyone understands these. For the scale factor, it has to be greater than 0. We can't have any negative side lengths like -4 or -7. So you're either going to completely get rid of a shape, which would be if it had 0, it would have no length, no width. So that would be possible. Excuse me. Oh my gosh. So that wouldn't be possible. And it can't have, again, any negative length. So therefore, it has to be greater than 0, and it can't be 0. All right. The other thing we want to note is that N can be less than 1. So when you think less than 1, again, most of you are thinking 0, -1. But remember, less than 1 means just like a fraction. It doesn't have to be a negative immediately. So for this, we're talking about if the scale factor is like a half, if it's a third, if it's a fourth, things like that that are less than 1 but still greater than 0. That's when it's going to be a reduction in size. It's going to be an enlargement when it's greater than 1. So anything that's greater than 1 would be an enlargement. So we're talking about, it could be like 1.1. As long as it's greater than 1, it's an enlargement. It could be n equals 10, n equals 6, etc. As long as it's greater than 1, it would be considered an enlargement. And basically the process is going to be to multiply the coordinates by the scale factor or the side lengths, and I'll clarify on that on the second slide. But when it comes to multiplying the coordinates by the scale factor, this is only going to happen if the origin, if the dilation is about the origin. Because if it's not about the origin, things will change. So let's go to the first slide here. So our first slide here is just going to give us some basic dilation examples. I have a couple here on this slide. I have 1, 2, and I have 3. So let's start with 1. So for number 1 here, it says triangle ABC has these coordinates. It says find the image of triangle ABC after a dilation centered at the origin with a scale factor of 2. So if you want to find the coordinates of A prime, B prime, and C prime, all you're going to do is take the scale factor and multiply it by the coordinates. So it's going to be 2 times 7, 2 times 10. So my A prime is going to be 14, 20. My B prime is going to be 8, -12. And my C prime is going to be -4, 6. Again, we just take each coordinate and multiply it by the scale factor. For the next one here, for number 2, this is a little different. I'm asking you what the scale factor is. Since this is about the origin, as it says in the directions at the top there, you could basically just look at one point. So let's look at A. A, the original point, is 2, 1. Those are the coordinates. And A prime, the coordinates are 6, 3. So if we look from A to A prime, how do you go from X to the new X? You multiply by 3. And the same things happens here. So that should allow you to figure out that the scale factor is 3. And you could look at all the points if you just wanted to be safe, but the scale factor is 3. Let's move on to number 3. And this is what you would do if you're given a shape, the coordinate plane, and the scale factor. So just like any of our others, you want to start off by plotting the original figure. So 2, -8, -5, -4, 5. I'm sorry, I should be labeling. That's Y, that's X. And then we have 4, 3. And that's Z. All right, and let me connect this. All right, so for this one, the scale factor, it says n is a half. So in your mind, you should already be thinking that this is a reduction, so it's going to get smaller. And all you're going to do is take the half, and you're going to multiply it by the coordinates. So 2 times a half is 1. -8 times a half is -4. For y, you get -2 and 2.5. For y, you get 2 and 1.5. All right, so now we're going to plot those new points and figure out what our new shape looks like. So it's going to be 1, -4. That's my x prime. -2, 2.5. It's my y prime. And 2 and 1.5. And that's my z prime. And then we would connect these 3 points. And again, we always want to shade in the new figure. So we'll shade it in like this. All right, go ahead to the next slide. All right, for this next one, dilation in the coordinate plane. I'm not going to graph this one. I'm just going to list what the new coordinates would be. Again, for this one, the scale factor is 2, and it says about the origin. So if it's about the origin, all you're going to do is multiply by the scale factor. So my x prime is going to be 2, 8. It's going to be 2, 2. It's going to be 10, 2. And again, you should be able to plot the points and etc. with no problem. All right, actually, let me show you this one really quickly. I'm gonna pause mine. So I just want you to see what the graph will look like. Okay, so the reason I wanted to graph this one is just to show you what to do. I thought it was gonna fully overlap, but this will just be our new one out here. So you would just shade it in. But just so you know, there will be some that'll look something like this. Let's say this is the original, and then this is the new shape out here. If that was the case, I wouldn't want you to like completely shade this in, so it's not obvious which one is the original, which one is the shaded. I'm sorry, which one is the new one. So what I would want in that type of situation, if you did have something, is for you to shade the outside. So that way I'll know it's the bigger one and not just completely cover the whole surface. All right, next slide. All right, here we go. A few more examples. Just dealing with some of these dilations. This one says CD was dilated about the origin by a scale factor of 2. So this is the primes. So the question here says, what are the coordinates of the original line segment? So we're looking for C and D, the original. So if the dilation was done with a scale factor of 2, then that means you multiply the originals by 2. So that means the original would be 2, 0, because you're going to divide by 2. And this would be 3, 1. So our answer would be B. All right, for number 2, we'll do a couple of these. I'll do like every other one. For the first one here, it says, what are the coordinates of A prime with a scale factor of 8.5? So the original A was -3, 3. And then we do that times 8.5 to figure out our new value. And it's going to be 25.5. So it'll be negative 25.5 and 25.5. For B, I do want to take a second to do that, even though I said every other one. I just want you to be clear on what a scale factor of 1 is. If the scale factor is 1, nothing is going to change. So E prime would just be the same point that we started with. So since E was 4, 1, E prime would also be 4, 1. Because we're not multiplying it by anything. We're multiplying by 1, it's the same as itself. For C, the original point was 3E3. I'm sorry, that's B. Sorry, I can't read my own stuff here. Looking at the wrong problem. For B, the original coordinates were 1, negative 3. The new values are going to be B prime is 1/4 and negative 3/4. And for E prime, I just wanted to look at that because it has a negative there. If the scale factor is negative, you would say not possible. Cannot be done. All right, dilation is not about the origin. So let's look over here at the two small graphs on the side first, then we'll get to the big one. If we were looking at this first example here where the two graphs are, if you look at C, you want to assign, like C is the point that the dilation is being done. If you look, there's no origin, etc. So C is the point, or it's the center of the dilation is the way it would be stated. So since I'm trying to find the scale factor, I want to focus on this center of the dilation being 0, 0. So C, I'm going to establish a 0, 0. Since C is 0, 0, then I'm going to say that this is the point. It's going up 1, not going left or right. So again, I'm kind of thinking of this is my origin. So that means that R is going to be 0, 1. And if you look at it according to the same plane, R prime would be 0, 2. So what happened to go from 0, 1, 0, 2? The scale factor is 2, multiplied by 2. For the next example, again, same idea. I would focus on C as the origin. So even though it may not be, that's going to be my origin. So C is my 0, 0. And then I assign values to one of the points. I'm going to go with A just because it's closest. So A is negative 1, 1. And A prime is going to be negative 2, positive 2. All right. So let's do the first one here. It says pre-image coordinates. So I'm just going to take a second and graph the original, and then I'll show you guys how to approach dilating this. Okay, so now that it's graphed, this one does not have the dilation centered at the origin. So in this case, it's going to be when it gets a little trickier. You're going to have to first determine, I would first graph that point of dilation, the center of the dilation. So in this case, that's negative 4, 3. So that is the point A. So at that point, just like we did with the rotations, you want to reestablish a new origin. So this is now my origin. Then I want to apply the rules here. So I'm going to now, instead of this being negative 4, 3, A is now 0, 0. B is now, this is again 0, so it's 1, 2, 3, 4, 5, 6, 0. Again, you go from this being the origin. C is 6, because it was already over 6, and then down 4, so 6, negative 4. And D is 0, negative 4. All right, and then we apply the scale factor, n equals 1.5. And now that we have it, like kind of at a center, sorry, not our center is like 0, 0, we multiply these by the scale factor. So A prime is going to be 0, 0 still, because 1.5 times 0 is still 1.5. 6 times 1.5 is going to be 9. I can't squeeze it there. I'm just going to write it down here. B prime is 90. C prime is going to be 9. And this is going to be -6. And D prime is going to be 0, -6. Again, you take the scale factor and you multiply it. If we just multiplied the scale factor by A and B and C as they were, we would not get the correct answer. Again, that would be about the origin. So now we're going to plot these new values. But again, these new values are going to be plotted from this new origin. So don't go back to the true origin, go to the fake origin. And AA is already here, so this is A prime. B prime is 90, so from here, this is 6, 7, 8, 9. So this is my B prime. C prime is 9, -6, so this is 9, 4, 5, 6. C prime. And D prime is 0, -4, -6. All right, so what our new figure is going to look like, again, you should know it's an enlargement because n was bigger than 1. And it's going to be this. So this is the shape. Like I said, I want you to just shade the outside here. Don't shade the whole thing so you can't see. So this is what I would shade. Now, to finish up this answer, you do not want to leave these coordinates because these are not actual coordinates for these points. It's, the faux coordinates so we can apply the rule. So the actual values, so do not leave this. The actual values for A prime, you want to go back to the original graph and go back to the true origin and assign values. So this is -4, 3. B prime is going to be, this was 0, so it's 6 over and 3 up, sorry. 1, 2, 3, 4, actually it's 5 over and 3 up, sorry. 5 over, 3 up. C prime is 5 over and 3 down, so 5, -3. And D prime is, here's 0, so 1, 2, 3, -4 and -3. So these would be the actual coordinates. All right. This next slide is looking at a few of the composites. Again, the composites are combinations of multiple transformations. The only one that really has like a special name is the glide reflection. A glide reflection is a combination of a translation followed by a reflection. Now, given the directions in a particular problem, it could be they want you to reflect first, then translate. It depends, you just follow the directions of the specific problem. But because you will get a different result if you translate then reflect, first reflect and translate. So you just follow the specific directions as to which one goes first to get the right answer. Multiple translations, we already looked at that earlier when we did the translations. You would just add the different translation vectors. Multiple rotations, you would just add up the degrees to get one big rotation instead of doing multiple rotations. And then if it's multiple reflections, you would just apply the rules as they come. So I'm just going to do these few practice ones underneath. And then on the next slide, I have a few that I'll actually graph. And that'll be it for today. So if I have 3 translations like this, I would just add these translation vectors. So I'll start with the first 2. We have -4 and 19. So that's going to give me 15. Now, this is written differently for this one. But again, by being x minus 4 like that, that means it's really -4, -8. So if you want to write it the other way, you can, so it's a little clearer. But however you want to do it. So all 3 of these are going to come together. So this first one's going to be 11. And then for the y value, it's -6 plus 7, and then -8. So -6 plus 7 is 1, and then 1 minus 8 is -7. So this would be the answer for those composites. It would just be one translation of 11, -7. These rotations, 270, this is counter, this is clockwise, this is counter, this is clockwise. So it's going to be 270, 270 degrees, minus 100, plus 90, because that's clockwise, which is, I'm sorry, counterclockwise, and then minus 120. Again, since clockwise is not the default, we're going to put negatives for those. So, and then we'll just go ahead and do this. Now, you could have, this is an option, combine the clockwise and then combine the counterclockwise and the clockwise and then subtract them, or you can do it one time, doesn't matter. So this is going to be 170 from these two, plus 90 minus 120. 170 plus 90 is 260, and then 260 minus 120, the final answer would be 140 degrees, and that would be counterclockwise since it's positive. If it was a negative, it would be clockwise. A reflection over the x-axis. So I'm going to write what happened there. If it's a reflection over the x-axis, it would have been x staying the same, y would change sign. Then it says followed by a translation down 3 and right 3. I'm sorry, down 3, right 5. So this is going to be right 5 will be x plus 5. Down 3 will be negative y, because it's already now a negative, and then minus 3, because it's going down 3. A rotation of 180 followed by a dilation where n is 4. So let's look at the first part. A rotation of 180, that rule changes the signs. So both x and y would now be negative. Again, not necessarily negative, but the minus there means a sign change. And then the dilation is 4. So you're going to multiply. I should have said a dilation about the origin, but it's about the origin there. And since n is 4, it's going to be negative 4x, negative 4y, because you're multiplying this by 4. And then the last one says a reflection over y equals negative x. And then I'm going to rotate it 90 degrees clockwise. So if I'm rotating over y equals negative x, remember that's when they switch places and they change signs. Oops. Oh, sorry. Oh, man. All right, sorry, I messed that up, but I'm back. So from here, again, you would first do the first part, which is to reflect over y equals negative x. Oh, man, what am I doing? So that'll be this, negative, negative. They're negative, and they switch places. And then you're going to rotate it. So this will be the first part. Then we're going to rotate it 90 degrees clockwise. So let me write down that rule. If you're rotating 90 degrees clockwise, they switch places, and this one changes sign. So this is already what we're dealing with after the reflection over the y equals negative x. So now we have to switch them again. So we're going to be looking at this. Switching again. So it's negative x, negative y. That's just from them switching again. And then this has to change signs. So this is going to be positive here. So this would be our answer. All right, so here I have one or two examples of the composites where we're going to graph them. I'm going to just pause the video and graph the originals, and then I'll graph the new ones with you. All right, so after I graph them, this is what the two triangles will look like for 1 and 2 on this slide. And again, these are composites, so it has two different transformations that we need to do. This is a glide reflection, which means it's a translation and then a reflection. So first is the translation. It says, and then reflect. So I'm going to do the translation first. Now you can do the graph of all three. I'm just going to list the coordinates and graph the final product. So if I'm doing the translation, my A prime would be, again, if I'm going down, left 3, up 4, it would be 6, 0, going down 3, 0 and negative 1. B prime would be negative 4 and 6. And C prime would be minus 3, 9. So these would be my coordinates. If I wanted to, again, I could graph that. I don't want to take the time to graph it or the space, it'll be too crowded. So now I'm just going to reflect it over y equals x. So when I reflect it over y equals x, the rule is that they switch places. So this is now going to be y, and this is now going to be x. They switch places. So now I'm going to list my new coordinates. So my a double prime, my final answer, is -1, 0. B double prime is 6, -4. And C double prime is 9, -3. And I would now be able to graph those points. So I'm going to plot this, and then I'll unpause it so you guys can see my final graph. All right, so in the end, after my translation and then my reflection, that's what it would look like. So if I act, some of these, again, will not require a graph. You would just need to know, like, how to go about figuring out those final coordinates. Again, just follow the order they're presented in. For number 2 here, it says you're going to rotate it 90 degrees about the origin. Again, if it doesn't indicate a direction, that means it's counterclockwise. So that means it's going to be y, x, they switch, and then this changes signs. So my x would be -3, -1. My y prime would be -9, -1. And my z prime would be -9, -4. Again, you can graph that if you want. I'm not going to graph both. I'm just going to now do the dilation. So now for the dilation, I need to use a scale factor of 1/3. So my x double prime after the rotation and now the dilation is going to be -1, and this will be -1/3. Now, let's be clear. It's not that the coordinate can't be negative when I was talking about the scale factor before. It's just that the scale factor itself can't be negative. So we get y prime, y double prime. That's going to be -3 and -1/3. And z prime is going to be -3 and -4/3. All right, so let's plot these points, and this will be my final graph here. So -1, -1.3, let's say it'll be right about there. And that'll be my x double prime. -3, -1.3. Sorry, try not to hold it too long so that won't come up. That's y double prime. And then -3, -4.3. -4/3 is like 1.3. So it's a little bit down. And this will basically be what this will look like. 1/3 of the original size, and it's being rotated. So that is it. Try some of the practice problems. There'll be one large exit card this week, and it'll be on Wednesday.